Hello, Mr. Long. This is FRQ number 4. Also with this paper, I drew out the diagram showing the problem because I forgot to print it. So, yeah. So for part A, it's asking to draw the feed by diagram. This thing is on a bank curve, so the box will be a little bit on an incline. Of course, FN will be applied, but also there will be components to the FN because it's on a bank curve, so it's going to have, so FN X will be there and FNY will also be there. And of course, since it's on the surface too, that's why FN's on there too. There will be an F of G, but there is no components like Fn of X or like the Fn of X. Like there won't be like an Fg of X or Fg of Y because this thing is not moving vertically. It's just moving around in a horizontal circle according to the problem. So that's why, yeah, there's no components like X or Y for the F of G. Moving on to part B. We need to draw the expression for the Fn on the car. So we can say that f of c equals to f and x. The reason why is according to this diagram, and I'm going to transition this right here. This will be, let me draw with a pen so you guys can see better. That's f of n, and it's going to have some components. Let me draw this here more. F of fnx equals fc because fnx is pointing to the center, fny is not. So that's why this expression is true. And we can say centripetal force is mv squared over r. Now, in order to get our radius, we need to transition also to fny because that's another component too. Fny equals fg because according to the diagram, they're both pointing up and down to, well, I don't need to draw it to the diagram, but fg is pointing down, fny is pointing up or down, I'm not sure. So we can say that. Another way to write f of g is m of g. And yeah, so that's your fn of y. And transitioning back here, in order to find this radius right here, so let me just write it again. In order to find this radius here, we go back here. This is, since it's horizontal, this can be considered your radius, and according to geometry, your angle will be right here because it's perpendicular, and you know geometry says so. And if we use this context here, opposite over adjacent will give your tangent. So coming back here, your tangent will equal r over h. If we isolate it to solve for r because we want to replace r, that'll be h tan of this. The reason why I'm simplifying now is this will help on with, I guess, with later problems. So I'm replacing with r with the value that we just solved for r. Let me just put r equals to h tan degrees of r. So can write that too. And in order to find f of n, since it has components, we can use Pythag to help solve for this because there is an x and y component. So fn equals, this is a quadratic formula, rad fn squared plus fny squared. So that'll be because you have components. So we already found the fn of x. That'll be nv squared over h tan pi to the squared plus mg according to the y squared. That's letter B. Now for letter C, the reason why I did h pi tan because it'll help for part C too. So part C is basically what we just wrote for part B, because it's asking to draw an expression for your your f of C. You already know that fn of x equals fc because they both point towards the center according to this right there. Fnx is pointing towards the center. Also, centripetal force points to the center. So we can replace f of c, and that equals your nv squared over r. And what we found, the reason why I replaced r for section B is so we can simplify for section C. By the way, I should have put part C right here. So according to this formula right here, h tan degrees equals to r. So we can say that f of c equals nv squared over h tan pi, and that is your answer. That's your f of c. Okay, so for part D, which is to derive an expression in terms of V. So, okay, so we can already use this formula right here. Fnx equals nv because it has a V component, and that is the expression we use solve for. And according, we can and what we can do is we can move the h tan over to the other side. Sorry, I just had a brain fart. H tan pi is equal to nv squared over, yeah. Sorry, my brother just came in the room by accident. So we moved the h tan over. So now what we can do is we can move the m over. So over m, right? So in order to solve, let me just also erase this out because we already moved it. So we could rat it, but I know in class there was a more simplified solution. I also wrote it in my notes. And, you know, after asking people just how to do it, so we can set our fn of y, like our previous problem right there, equals to f of g. And actually, I don't even need to write f of g, because we can write f of g is just weight, so m of g. And fg y is fn of sine. So equals mg, and then we can move that to the other side. So that's our fn. We can now we can set up fn of x now equals to fn of cos. And we can simplify fn to what we just found right here, fg sine. So instead of Fn, we'll replace it with mg cos over sine. Right there, hopefully you can see it. Now, with all of this, we can plug all of this into Fn of x. So, mg cosine over sine. And for h, instead of tan, I'm going to simplify even more because tangent is sine over cosine. So, over m equals v. This is a square right here. Can add that whole thing right there. Cosine cancels out, sine cancels out, m cancels out. So you are left with rad gh equals to v. And that is, it for part D. Now, for part E, is asking for Vmax. So now, since there is a Vmax, there should be an f of s too. So we can put, since there's going to be, friction, of course, there's going to be f of s, but also that f of s is going to have components too. So right here, or I should put like a dot. Yeah, cool. Fs of y, s of x. And since it's v max, for now, this fs of y will be pointing down because it's v max. So, with that information, f and x, we need to find out which ones are pointing towards the center. And fs of x, fn of x is pointing towards the center because it is, like, that's fs of x. It's horizontally pointing towards the center, and fn of x is also pointing towards the center. And that will equal f of c because fc always points to the center too, because that's true. So, you're given, we can place this with cosine pi, but f of s now, f of x will be fs sine theta, because now the angle is on the y-axis now. It'll be like, right on there. It's on the y-axis. So fs of x now will be sine theta equals to f of c, or instead of f of c, I can write this centripetal force formula, and I can simplify the Fn. And f of s is also has mu. It's mu Fn, but we are factoring m and Fn out, so we can just say mu sine of theta goes V max over R, because we're solving for V max. Now we can, we need to find what the heck this Fn is, right? So now we're going to solve for the vertical components. So these are our vertical components right here, because according to the graph, should also label that f of g goes down to f of g, fn of y, and fs of y is, this is pointing down, by the way, fs of y, because it's Vmax. They're all a vertical component. They're all being pointed down or up. So that's why they're all, well, in this case, FG, Fs of y is pointing down. They're all vertical components, and also they're not pointing towards the center. So that's why we group these verticals together. So Fn sine, because that angle for the Fn is on the x, minus Fg, which is mg, minus, we can do mu because it's Fs, it's going to be friction. Fn cosine of 0, because this angle now is on the y-axis because of geometry. So can factor out the Fn, and also we can move this mg over to the other side. So that will give Fn equals mg over sine minus cosine. And now we can put this equation onto Fn because we already solved for Fn too. So mg over sine minus cosine, and I can just put this on top right here. Mu s equals to mv max over r. We can move this r over, the m's cancel out, multiplying the r over, we can get rad, because this is v max, g r cos plus mu of sine over sine minus cosine. And that will be your V max. For part F, we want to find V min. So it's the same thing, really, but now Fs will be pointing away. So it won't be pointing here, that's V max, it will be pointing away, like out of the center. And Fs of y, since it's V min, would now be pointing up instead of down. So now with that in mind, we can solve for part F. So it's the same exact thing, it's just some sign terms it might change. Instead of plus, it's minus, because F of S, F, the friction or static friction of X is not pointing towards the center, it's pointing away now. So that's why it's minus, but it's still part of the horizontal or center component. So we can simplify this. Again, it's just the same thing like part E. And this time, so Fs will put the formula for centripetal force. So V max, V min over R. Now we have a vertical component, Fn of y minus f of g, but this time we're going to plus Fs of y, because now it's moving up, because it's V min now. So, and that was set equal to 0. Now we just replace all the formulas. Fg is mg, Fn sine theta, mu because f of s, of Fn of cos, because it's on the y-axis, so the Fs of y now would be cosine. And now if we simplify all of this, it's the same process as what we did here. You should get Fn equals mg over sine plus mu of cosine. Now we plug in Fn into here, but before I do that, I should probably also factor this out too. So cosine minus mu sine equals mv min squared over r. And now we can put this expression we found into f of n. So mg cosine minus mu s sine theta over sine theta plus mu s of cosine equals to this right here. We'll move the r over, m's cancels out. So the answer you'll get for v min is the same thing. You're going to have to radical this whole thing. Equals to rad g r cosine of mu s sine theta over sine plus mu of cosine. So that'll be your v max or v min, and that makes sense because this is like the formula we had to memorize, and they both match. So now we move on to part G. It's asking to prove that expression that we had to memorize. I'm going to say that F net equals FC because this problem is horizontal too. It's a horizontal circle, and they both accrued in the x direction. So they both have to be pointing towards the center, or yeah, close to the center. So instead of F net for now, we can just write FC because we already proved this because of x direction. FC equals NV, and for this one I'll use the NV max over R, and we already found FC, we already found V max according to part letter E. So our V max, so we can replace our V max with M. We can add this whole thing. GR S and again, the reason why this V max, I already memorized this, and I know this is one of the powers you need to solve, and that is a V max expression with the cotangent. So I think so, I'm not sure, but we get that, and then this radical would be canceled out too, so it will be FC equals mg of r, because this radical times the square will equal the original function. Cosine, forgot to put an angle right here too. Cosine plus mu s sine over sine minus mu of cos all over r. The r's would cancel out, so you are left with f of c equals to mu. But what I'm gonna do before I write this down, I'm gonna write that cosine, or cotangent, sorry, not cosine, is equal to cosine over sine. So I already know we can simplify this more. So by dividing all of this over by sine, right, this will become cotangent, this will become 1, this will become 1, this will become cotangent, and that will equal our expression. So we can do, we're going to draw really big, so we will divide all of this by sine. And then we divide again, this value right here, and also divide by sine again, because that will help give us the cotangent that we need. and to cancel out any signs. And that would give you, since we already drew this conclusion, f net equals fc, I can now, instead of f sub c, just put f net equals to cotangent plus mu over 1 minus mu as cotangent of m of g. And look at that, that's the same one, and we just prove all of that. So it's a very tedious FRQ. Sorry for the amount of stuttering and the shakiness of the phone. Thank you.